So what we're going to be working on the next few days is how to model real-world functions with a sine or cosine wave. So anything that goes back and forth between the same values or up and down between the same values can be modeled with either a sine equation or a cosine equation. So we're going to look at one example in detail. So first, just read through the scenario carefully. It says Brielle and Elaine always travel to Sunset Beach together for their summer vacation. Through the years, they return to the same section of beach and spend their time around the pier. Elaine has noticed that the water rises and falls on the posts of the pier. She thinks that the height of the water could be described as a sinusoidal function of time, because that's what everybody does on their vacations, right? Brielle was snorkeling and noticed that the pier posts are slimy up to the lowest level of the tide, which was 2 feet for this particular post. Since Brielle and Elaine were on vacation, they had nothing better to do and found out there was a low point on the post at 8 o'clock in the morning and a high point 40 inches higher at 2 o'clock in the afternoon. So our first goal is to find an equation for the height of the water relative to the post as a function of time from 12 o'clock midnight. So first thing, we just want to make sure we're being consistent with our units. Some of the heights are measured in feet and some of them are in inches. It'll probably be easier to convert everything to inches. And then the time is from 12 o'clock midnight, so that means that they're using like military time. So 8 o'clock would just be 8 o'clock, but 2 o'clock in the afternoon would be like 14 o'clock. So the next thing that you want to do is just draw a general wave. You don't want to get bogged down too much in like where the x and y axis should be, how to scale your axes. Just kind of a general sine or cosine wave is good. And then what we're going to do is label some of the key points. So the first piece of information that they tell us is that the lowest level was 2 feet. So that's going to be a y value. So we're going to want to label one of the minimums with 2 feet, or like we talked about using consistent units, 24 inches. And then the x value, the low point was happening at 8 o'clock in the morning, so we put 8 o'clock there. And then the next thing that they tell us is that the high point is 40 inches higher at 2 o'clock in the afternoon. So 2 o'clock in the afternoon would be 14 hours after midnight. And then 40 inches higher than 24 would be 64. And that's pretty much all you need to write a sine or cosine equation. What we want to do now is start picking out some of the important information that you need to write an equation. So for example, right after the equal sign, we normally add in the amplitude. So easy way to get the amplitude, find the span between the highest and the lowest. And we can see that that's going to be 40 inches. So the amplitude is just going to be half of that because the amplitude is the distance from the middle to the top or the middle to the bottom. And then after that normally comes the sine or cosine. We can technically use either. After that usually comes the b value, which is the horizontal stretch or compression factor. So we get the b value from your period. So to go from bottom to top, that takes 6 hours. So that means the entire period will be double that, or 12 hours. So if I wanted to go from bottom to bottom or top to top, because it's symmetrical, that means the period overall is going to be 12 hours. And then I use that to help me find my b value. B is 2 pi over the period, so 2 pi over 12. And then the horizontal shift is going to depend on which point we use for our sine or cosine equation. So the last thing we need to identify is our midline. So there's a couple ways of identifying the midline. One is to find the average of your max and your min. So if I took 64 and 24 and added them, that would give me 88. And then divide that by 2, that would give me 44. So our midline is 44. Another way to do it is to add the amplitude to the bottom. So we know that from here to here is 20. So if I do 24 plus 20, gives me 44. I could also take away the amplitude from the top. 64 minus 20 is 44. So now we should have all the info that you need to write your equation. We just have to decide whether to use sine or cosine. It doesn't really matter. I guess in this case cosine is going to be easier because cosine starts at the top. So if we choose this point right here, we can use a cosine equation and don't have to figure anything else out. If we wanted to do sine, we'd have to figure out some information about this point in the middle of the graph. You could also use this point if you wanted to. You would just have to do a flipped cosine equation. Remember that there's lots of different ways to write an equation. All right, so we put it all together. We can do y equals, the amplitude goes first. We chose to use cosine. After cosine, we put the b value, which was 2 pi over 12, which we can reduce to pi over 6. And then next to that goes the horizontal shift. So if we're using this point right here, we had to shift the parent graph to the right 14. So you can use x or t, either way is fine. And then at the end, we put the vertical shift, which is the same as the midline. So the 44 goes there. All right, once you get your equation, a good way to check it is to plug in the values that you know to be true. So grab your calculator, make sure that you're in radian mode, and what you want to do is try plugging 8 in for the place of x. So plug 8 in for the place of x, and you should hopefully get 24 out as an answer. So pause this video, plug it in your calculator, make sure that it works. All right, once you check that point, a good idea would be to check the second point as well. So take this 14 and plug it in for the place of x. So type in your calculator 20 cosine of pi over 6 times 14 minus 14, and then plus 44, and then make sure that you get 64. Pause the video if you need to check your work. All right, the next couple questions are asking us to do some predicting. So it says at 11:30 a.m. the girls wanted to take a walk on the beach but decided to wait until high tide. What was the height of the water at 11:30 a.m.? So this one's not so bad because this is a time, so all we have to do is plug it in for the place of x. 11:30 a.m. would be 11 and a half hours after midnight. So all you want to do is take your calculator and plug in 11 and a half for the place of x. All right, so after you plug in 11 and a half for the place of x, just write down your result. And we should hopefully get 49.2 about. And then since y is a height value, that should be measured in inches. So that problem's not so bad because basically when you plug in an x value, you only ever get one y value because we have a function. The last problem is a little bit trickier because you're solving for an x value. So it says that Brielle's little brother Sean is 2 feet 7 inches tall. When is the first time after 8 a.m. that the water will be over his head if he plays right next to the post? So they're giving us a y value and we have to solve for an x value. And we have to be careful because if you think about what a wave looks like, it's going to equal the same value over and over and over again an infinite amount of times. So we're going to have to take an infinite amount of answers and then figure out which one makes the most sense. So it says that he's 2 feet 7 inches tall. So right away, if we convert that to inches, that would be 31 inches. So the first step is to plug 31 in for the place of y. And then after we do that, we want to work towards solving. So the first thing that we're going to do is subtract 44 from each side. And then we're going to have to divide by 20. So at this point we have cosine by itself, so you want to do the inverse cosine of negative 13 over 20 in your calculator right now. If you do that, we should get about 2.278. And what's a little bit different about this problem is that's not our final answer, because we still have stuff inside the cosine that we need to solve for. But at this point, what you want to do is actually write a second equation. So when we did inverse sine, when we were in radian mode, we had to do pi minus to get the second possible answer, or in degree mode, 180 minus to get the second possible answer. So what we're going to do with cosine is think about how do we get the second possible answer with cosine. So if cosine is negative 13 over 20, it might look something like that. The calculator gives us that 2.278 answer. And then to get the other answer, it would just be the same angle in the opposite direction. So our second equation is going to be the same as the first equation, except for instead of a positive 2.278, we are going to have a negative 2.278. All right, then we need to solve each of these equations separately. So we can divide by pi over 6, which if you do that, you need to make sure that you do that in parentheses. Or you can multiply by the reciprocal, which is 6 over pi, and then add 14 to both sides. So take a minute to put this in your calculator, pause the video, and then check your answer when you're done. So solving the first equation, we should get 18.351 about. And then the second equation, about 9.649. So the last thing that we need to keep in mind is that these answers are two answers out of an infinite amount of answers. So the way we get the rest of them is by adding multiples of the period. Up until this point, the period has been either 2 pi or 360. But if you look back at our question A, we solved for the period of this one as 12. So that means to get more answers, we're going to add or subtract multiples of 12 from each of these. All right, then the last thing we have to do is make sure we answer the question. It says, when is the first time after 8 a.m. that the water is going to be over his head? So this right here, 18 o'clock, is about 6 p.m. We can make this answer smaller by subtracting 12 from it. And if we did that, we would get another possibility of about 6.351. So that's earlier than our other answer, but it doesn't meet the criteria that it's after 8 a.m. because this is going to be sometime during 6 a.m. So this answer doesn't work. And then this answer right here, 9.649, is after 8 a.m. If I tried taking 12 away from that, that would go into the negative. So basically this is your answer here. The only thing you might want to do is change 0.649 hours into minutes. So in your calculator, put 0.649, multiply by 60, and that'll give you the number of minutes, which should be about 39 minutes. So our final answer should be at about 9:39 a.m. So when you're solving these types of trig equations, most common thing people forget to do is find the second distinct solution and to check whether they can add multiples of the period or take away multiples of the period to get bigger or smaller answers. So those are the things you're going to want to be careful of.